So hey, how's it going, everybody? My name is Carlos Mariscal. I have been at all of the socials. I hosted the last one, and I've been really focused on uh, issues in astrobiology from a philosophical perspective my entire career, essentially. So I'm at the University of Nevada, Reno, in several departments, including philosophy. It's probably of no surprise to anybody that one of my motivating questions, at least anybody that knows me, is that one of my motivating questions is, can we know anything about life elsewhere? And in various forms and various publications, I've said things uh, that will cement me in the yes answer to this. Right. So I have talked about convergence in evolutionary theory. I've talked about origins of life. I've talked about universal biology, and I think those are more applied versions of what I believe. Today, I'm going to take a step back and ask a bit of a more conceptual question, and that question is what we know about life elsewhere, or what we could know about life elsewhere, due to what we know about physics? And the answer to that is going to be no. So I like to tell my students that I never want any surprises in any presentations or any articles or anything that they write. So I just told you what I'm going to tell you, and then I'm going to tell you it, and then I'm going to told you that, or tell you that I told you that. Right? So um, this is eventually what I'm going to say. I'm going to say that the proper way of understanding evolutionary theory, or the underlying logic of evolutionary theory, is that it does not depend on facts about physics as we actually know it. It might depend on some other assumptions that we might call a possible physics, but not on the laws of physics as we know it, or the way the universe is organized as we know it. So I'm going to say that later, but I'm just foreshadowing that now. And also, I don't want to let too long go before I tell you why you should care about this. So if you agree with the first point, then I don't need to argue any of the rest. Maybe some philosophers already care about this. Maybe some people that are just interested in astrobiology already care about this because they want a deeper conceptual understanding of life in the universe and our study of it. Another reason you might care about it is justifying scientific practice. There's a distinction between a default explanation and a special explanation. I don't need to explain why I haven't levitated, for example. That's the default. If I did levitate, then I would need to explain that. So if there are features of biology that are universal, if um, evolutionary change is thought to be a natural consequence of some basic assumptions about not just life, but other other circumstances, then that doesn't require any special explanation, but perhaps lack of evolutionary change, or uh, lack of uh, or extreme evolutionary change might require special explanations. I'm always interested in universal applicability, and I think that gets really, really hard. So you have to focus on saying precisely what you mean and how you mean it. And I am of the view that there are different degrees of universality, or to put it another way, the domain of the universal uh, changes. And when we talk about uh, physics, we think that it applies to every single item in this universe, not realizing that there are some features in this universe that the facts on, you might require objects in order to get 2 plus 2 to equal 4. You might require countable entities. But even if the laws of physics were completely different, if there were countable entities, 2 plus 2 of those entities would still add up to 4, even if the gravitational constant was fundamentally different. I'll say more about that in a little bit. And finally, I don't have a lot of trust that physics is the physics that we know now is the final physics that we'll have. So if it turns out that the grand unified theory leaves out relativity or quantum mechanics or some aspects of statistical mechanics, if it turns out that dark matter and dark energy means that we actually need to rethink our laws of physics, I don't think we need to throw out all of biology. I think there's a lot that we can still accept, even if the physicists, when they finally get their house in order, get it in order in ways differently than we expect. All right, so third of the presentation done. The next third, I'm going to say what I told you I was going to say, and then the last third, I'm going to tell you that I told you that. So essentially what I'm going to do is talk about evolution as entities plus history. And I'm going to challenge a way that people have traditionally cut this up, this way of understanding this up, and just question that way of dividing up our thinking about the various sciences. And then I'm going to tell you how you could attack my view. So I'm a philosopher of biology by training, and no philosophy of biology talk is complete unless somebody references Richard Lewinson's 1970 paper, where he says, okay, this is what we mean by evolution by natural selection. And a lot of people have spilt a lot of ink about how much he's got right, what the details are, whether you can get things that resemble evolution without this or whatnot. But we keep coming back to it for a reason. There's a simplicity here. And maybe I can make this simplicity a little bit more clear by just pointing out that there's the logic of it is pretty straightforward. So first, Lewinson doesn't specify this, but I'm being a pedantic philosopher, so you got to be talking about something, a system that interacts with its environment. And there are variations within that system. Those can be retained across time. Some of those do better or worse in the environment. And holding all of the 1 through 4 together, you would expect that over time the system will tend to be composed of variations that did well in the past than ones that did poorly. It's guessing and checking over millions of years. You got to remember what you guessed, otherwise you can't quite check it. But that's it. It's very basic. It's one of the things that's so frustrating about evolutionary theory is how simple the logic was. And it was obvious to Darwin and to T.H. Huxley. He famously says, after he reads The Origin, he hits himself over the head and he says, why didn't I think of that, about that? It's a simple idea. It took a lot of people a lot of time to come to grips with it. And you can think about it just as these 3 features: variation, some form of heredity, although that has technical meaning in population genetics and other branches of biology, so I won't say those, and fitness, but again, has technical definitions in various subfields, so I won't mention those. Poorly or well. And if you really, really, really want to be maximally pedantic, if you don't include that those variations caused it to do poorly or well, you just have evolution. But if the variations are the responsible, it's evolution by natural selection. Again, super pedantic, don't need to say any more, except to point out that there can be variation in how much variation you have. You can have identical populations of clones, or you can have populations that are extremely different. You can have things that are completely heritable or not heritable at all. They disappear within a lifetime. And you can have organisms that perform equally well, or where some live and some die and nothing in between. And I want to point out that these variations happen here on Earth in various populations across various traits. So, okay. So that's the basic logic of it. There's been so much work done in evolutionary theory trying to understand how it works here on Earth over the past 150 years. A lot of it really good and really interesting. Not most of it essential. I just want to point out that at the root, the logic is the same as that of historical change. Early events matter, and the details matter in terms of explaining the kinds of change, the kinds of results, and the rate of change. The entities and the rate of change matter. So you might look at a petri dish and neurons and cultural evolution and artificial evolution, astrobiology, and say, whoa, 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 Carlos, I have thought about these issues for a long time, and anybody that's tried to apply evolutionary theory to culture has been completely wrong. They're too they smuggle in too much, and it turns out that variation is murkier than that, and they blah blah blah. Like, okay, sure. Maybe evolutionary theory, the way it's understood in biology, that deserves the term evolution, and everything that we have attempted to generalize from it is we should just call schmevolution. Fine. The point is, schmevolution is constant. It's rampant. It's everywhere. It's very, very logical. Okay. So section 2. How have philosophers thought about evolutionary theory and biology before? Well, many different ways. One way is distinguishing between reductionism and anti-reductionism. And typically, the debates go into details like this, right? So does biology have natural kinds? Like, is there such a thing as a species or life that is distinct, that cannot be explained by fundamental physics? Reductionists say no, anti-reductionists say yes. Are all biological explanations enhanced by appeal to physics? Reductionists say yes, anti-reductionists say no. Is biology an autonomous science? By virtue of the first two, reductionists say no, anti-reductionists say yes. Cool. And so this is typically how they break it down, right? So anti-reductionists will think about evolutionary theory as sort of a subset of physics in some way. Reductionists will say that. Anti-reductionists will think, no, evolutionary theory or biology is autonomous from physics. Maybe a principle of natural selection is a law of its own. I don't have much to say about natural kinds. I have been skeptical about them. I'm troubled by them. I could talk about it at length, but I just find that this, to throw back to essential thinking in Aristotle. I also don't know what it means to be autonomous. And I agree with the anti-reductionists on the middle point. And so if what I said in the first part is correct, I disagree on the autonomous point. Then you might say, okay, well, yeah, but what you said presumed that there was a system with entities. Cool. All right, call that possible physics. But that's just what there is. There could be a different world. Sorry. All right, now I'm at 15 minutes, and I'm going to wrap this up very quickly. How to attack this view. Other kinds of physics and biology must be possible. Non-physical facts can be explanatory, and I have approximately the correct account of evolution. I'm not going to say much about 1 and 3. I think that's a judgment call, and we can have a debate about our values and about what you think gets to count and what gets to be the right account of evolution or schmevolution or whatever. But the second one about about non-physical facts being explanatory, the traditional way of arguing this is square pegs don't fit in round holes. It doesn't matter. Like that's the level of explanation you need. You don't need to know about whether these are made of metal or wood or whatnot. Cool. Oh, they don't fit. All right. That's the traditional way of doing it. The way I like to think about it goes to Mark Lang and to some of the work done in philosophy of mathematics about what counts as a distinctively mathematical explanation. That is to say, sorry about that. That is to say, if I'm trying to divide 3 strawberries among 2 people, I can't without cutting one of the strawberries. I can't. No fact of physics except for the fact that I have countable objects is relevant. So the math is what's explanatory, although it does invoke the fact that there's some possibly countable object. That's the same thing that's going on with biology. So that's where I wrapped up. And I want to say, in sum, evolution is not derivable from physics. It's just some basic logic. If it's not derivable from physics, then it's plausible that there are some more robust, more generalizable, more universal features of evolutionary change than the laws of the universe, which realize those changes. And alternative accounts of evolution, maybe they don't reveal biological evolution, but they reveal something about schmevolution. All right. Thank you. Sorry about the length.